Okay, we're just talking about complex numbers in the previous video, and now we're just going to talk about multiplying complex numbers. Okay, so in the previous video I showed you how we might multiply by a scalar. Okay, so 3 times a complex number. Okay, but what we're going to do is actually multiplying. So we've done that, that's fine. What we're going to look at now is how to multiply two complex numbers together. Pardon me. So if we've got a complex number there, what happens when we multiply it? Yikes. By another complex number. And all the same rules from previous work in algebra and numbers still follow. All you've got here, you've got something with 2 terms multiplied with something else by 2 terms. And your rules apply, and in fact FOIL applies. So we multiply the firsts, outsides, insides, and last together. This still works for complex numbers, and I'll prove this in class. And so what do we have? So let's just work it out. 2 times -2, -4. 2 times positive 2i is positive 4i. 3i times -2 is negative 6i. And 3i times 2i is 6i squared. Okay, and then we just need to simplify what we have here. Okay, so what's that equal to? Well, we have a -4, because that's the only number there. Or is it the only number there? In fact, what is this thing here? 6i squared. If you remember, what is I squared equal to? I squared is equal to -1. Okay, so I'll come back to that in a second. We've got positive 4i, negative 6i there, that's negative 2i, and we put them together. And 6i squared, positive 6i squared, if I squared this here, I squared is equal to -1. Okay, that's equal to -1. So what do we actually have there? That's actually -6. Okay, that's positive 6 times -1. So just finish that off. -4 minus 6, -10 minus 2i. Okay, and there you go. That is your complex number there, your answer. So that's how we multiply two complex numbers together. Maybe just a couple of other examples, but that's all there is to it. How about if we have 2i times 5i minus 2? Here we've just got the complex number written in a different way. Don't let that confuse you. It's still exactly the same, just written in the opposite order. Again, just multiply things out exactly how you do it in algebra. 2i times 5i will be 10i squared minus 4i, multiplying those two together. And what do we get? What's 10i squared? Remember, I squared is -1, so you get -10 minus 4i, and there we go. There's your answer there. Too easy. Just the last sort of thing is just to find, well, what's I squared equal to, what's I cubed equal to, I4, I5, I6, and let's just do, I'll squeeze it in, I8. Let's just have a look. I squared, we know, is -1. Now I cubed, what's I cubed equal to? Well, that's I times I squared, isn't it? So that means I squared is -1, so that's actually -I. What's I4? I4 is I squared times I squared, which is -1 times -1, which is 1. What's I5? I5 is I times I4, which is, I4 was what? I4 was 1, so that's just equal to I. I6 was I squared times I4. I4 is just 1. What was I squared? -1. Okay. I7 is I cubed times I4. Remember, I4 is 1. What was I cubed again? -I. Okay. And what you see is, because I4 is equal to 1, here, this one, and what happens is that this pattern just keeps repeating and repeating and looking at the powers of I. So what you get is I4 is equal to 1, and then after that it just keeps repeating -1, negative I 1, and then it goes back to I again. So you'll see that happens again. So negative 1, negative I. What will I8 be? That'll be 1, and then the pattern just keeps repeating. Okay, so that's really quite easy to look at. So if you're trying to figure out what's I to the power of 71, then what would that be? Look at how many multiples of 4 go into that. Why did I choose such a ridiculous number? What's the closest power of 4? So that would be I to the power of 4 to the power of, what's 71 for 4? 40, we'll get 28, so 68 will be 68, it's a multiple of 4 anyway, that will go to 68 multiplied by I cubed. Okay, so 68, oh, what's 68 divided by 4? Will be 17. Okay, I to the power of 4, 17 lots of that. And then multiply what's left over, because that gives you I 68. 68 is divisible by 4, and then you've got I3 left over like that. And so that's just equal. That's just there is equal to 1, and so it's just equal to I cubed. I cubed is just negative I. So just sorry, it was a bit messy what I did there, but this is how you just get this continual repetition. There's only really, if you're getting multiple powers of I, then you're only getting these different solutions here. Okay, sorry that was a bit messy, didn't explain that. I'll go over that again in class.